What's the other side of 0? What's the other side of 0? Do we have
Negative.
anything? Because few of you said starting number is 1. Few of you said
Negative
starting number
numbers.
is 0.
Negative numbers, man.
Negative
Integers.
numbers. Very good, Dhananjay.
Integers.
Okay, integers. So I can see one of you know about integers. Someone knows about integers. Ashrita, that was right.
Yes, ma'am.
Okay, good. Okay, now, so I see you all know a lot about numbers, you know about the starting number. So now I'll be starting with my PPT. One small request, everyone would be on mute, but obviously you can speak up by taking your turn, raising your hands, okay? Feel free to come up with your thoughts and doubts. Fine, all of you? Thumbs up?
Okay.
Okay, great. So the other side of 0, what's the other side of 0? As someone said, the other side of 0 is nothing but the negative numbers. Okay, so basically students, we have three sets of numbers: whole numbers, natural numbers, and negative numbers, which are also called integers. Fine. Now, when we talk of these numbers, and the first question that I asked you was the first number, right? Few of you said 0, few of you said 1. Both are not wrong. Depends on what is the set of number that we are talking of. Because few places in mathematics, 1 is considered as the first number since 0 has no value. Whereas in few places, 0 is considered as the starting number. Okay. So, whole numbers. Whole number is a set of numbers that includes all the natural numbers. Now, what are natural numbers then? Natural numbers are basically numbers starting from 1 to infinite. There is nothing called last number. I hope everybody knows that, right? So there is nothing called last number. So the first number is 1 to that infinite. That's the set of natural numbers. Okay, all of you? The moment I add 0 to this set of natural numbers, it becomes whole numbers. The moment I add 0 to this set of natural numbers, it becomes whole numbers. Furthermore, the moment I add negative numbers to the set of whole numbers, it becomes integers. Am I clear, all of you? Am I clear?
Yes, ma'am.
Yes, ma'am.
Yes,
Very
ma'am.
good. Anyone any queries?
Yes, ma'am.
Anyone any queries?
No, ma'am.
Excuse me, ma'am.
Yeah.
Ma'am, I didn't understand how natural numbers can become whole numbers and how whole numbers can become natural numbers.
Okay. See, actually, they are set of numbers. They're not becoming. Basically, the set is getting enhanced. It is getting enlarged. Okay. So when we start from 1 to infinite, that's a set of natural numbers. So I'm extending the set further by simply adding the number 0 to this set. So 0 to infinite becomes whole numbers. Again, I'm extending the set of whole numbers by adding negative numbers to them. So negative infinite to positive infinite. That's the set of integers, which we are going to speak of or learn today. Okay, Parinita? Okay, all of you? Atharva, okay?
Yes, ma'am.
Okay. Next, integers. As I use the term 3 or 4 times till now, what is integer? It is actually derived from the Latin word integer, which means whole, something whole or intact, which is not changing. Integer, it's intact. Intact as in how is it whole or intact over here in terms of mathematics or digits or numbers? It's intact as in it's intact in its value, irrespective of its symbol, positive or negative. Am I clear? It's intact of its value. Okay. Now, when it's intact of its value, we call it absolute value. We call it absolute value. This absolute value is represented using mods. This is a symbol of mod. Suppose I write mod minus 5. The value to this is 5. Suppose I write mod 5. The value to this is also a 5. That means absolute value or the intact value is nothing but the numerical value just irrespective of the symbol. Clear, everyone?
Yes,
Yeah,
ma'am.
Yes, ma'am.
clear? Is she okay? Yeah, Arav, you want to ask something?
I don't get like the meaning of intact.
It's like it's something is intact means as it is,
Okay.
right? That's the dictionary meaning of the word. So it is as it is. So over here, obviously, it is as it is means what? Is it an object that's not changing? No, right? It's in terms of numbers. Excuse me. It's in terms of numbers and digits, right? So when we are using this term over here in respect to numbers and digits, how are we, representing it? How are we representing it? We're representing it as in the absolute value to the number. Now, when we are using the word absolute value, we use it using this symbol, which I just told you, mods. And this symbol, whenever we are putting this symbol around a number, it signifies the number is going out just with the numerical value. The sign is not getting carried forward. Okay, Arif?
Yeah, thank you.
Yeah, you're most welcome. Okay, Sudhir, Dhananjay, Agastya, anyone any queries?
No,
Anyone
ma'am.
any queries? No?
Excuse me, ma'am.
Okay. Yeah,
Ma'am, what is the spelling of the word motor?
mods.
Mods. Okay.
MOD, mods. Okay?
Yes, ma'am.
This is a symbol that's not used. Usually the term used is absolute value only. Absolute value is the term used. Okay?
Okay, ma'am.
Okay, next coming to number line. Number line is quite similar to the scale or ruler that you use in your day-to-day life. Okay, students? It's quite similar to the scale or ruler if you see the one which is below, just drawn over here. Visual representation if you find. Over here, what's a number line? A number line is basically numbers on straight line. If I'm representing numbers on something like this, that's not a number line, firstly. Secondly, two things are to be kept in mind. One, it should be a straight line. Secondly, the numbers should be at equal intervals. Suppose I draw a straight line, I write 0 over here, then a 1 over here, then a 2 over here. 0 to 1 and 1 to 2, is it equidistant? No, right? It's not
No, ma'am.
equidistant. So, this is not a number line again. Clear, all of you? Is she okay?
Yes,
Good.
ma'am.
Okay. So, this is a number line. Now, very interesting few facts are associated to this. Okay, can anyone tell me what's the task of a mirror? What does a mirror do?
Ma'am, for reflection.
Ma'am,
For
a mirror
reflection.
gives the opposite image.
Ma'am, for
Very good.
reflection.
It shows your reflection. But does it show your reflection exactly? Is there any twisted version?
Ma'am, it shows
Yes,
the
ma'am.
opposite.
Shows the opposite.
It shows what you're placing in front, but the sides alter, right? The left and right, that alters slightly. Correct.
Excuse me, ma'am.
So, yeah,
What does equidistant mean?
equidistant means equally distant. Like 0 to 1 and 1 to 2, they are equidistant, equally distant to each other at
Okay.
equal interval. Okay? Okay, proceeding with this. So, why did I use the word mirror? Because in the number line, 0 acts as the mirror or the center. Okay. Now, why as the mirror? Because 0 does the job of exactly what a mirror does. It reflects the left-hand side and the right-hand side. The left-hand side is nothing but the reflection to right-hand side, but with a twisted form. When you go further right, the value increases. The more you go rightward, the value increases. Hence, the twisted version is the more you go leftward, the value decreases. Got it, everyone? Hence, this makes 1 the smallest positive integer, whereas -1 is the highest negative integer. -1 is the highest because the more you're going leftward, the value is decreasing, right? So if I'm switching from -2 to -3, it's decreasing. That makes -2 greater, isn't it, all of you? Right, Ritesh?
Yes, ma'am.
Yes, ma'am.
Yes.
Yes, ma'am.
So very quickly, can anyone tell me which one is bigger?
Ma'am, minus 75.
Ma'am, negative 75.
Negative 75. Very good. Negative 75. Okay. Now, over here, the first slide that we had of numbers and its different sets, over here, the visual representation is given in the form of Venn diagrams, natural numbers, 1 to infinite. Again, a further bigger set or area of numbers, 0 to infinite. Again, a further bigger area comprising all the numbers, negatives, positive. Anybody who is using the chat box, please do not. You can obviously communicate verbally, because the chat box, I'm not switching it right now, okay? So it's not accessible for me right now. So please do not use the chat box. Okay, so integers. So Ishi, can you tell us what this picture shows us? Can you derive a conclusion from this?
Ma'am, it shows us the integers, whole numbers, and the natural numbers.
No, that's visible. Like, can you draw a conclusion from it? Any conclusion that's coming to your mind? Anybody want to try? Yes, Dhananjay.
Ma'am,
Ma'am, that integers have a bigger value. Like they have more numbers. Whole numbers have lesser than have more numbers than natural numbers, but less than integers. And natural numbers have the least set of numbers.
Okay. Anyone else? Atharva, you were trying to say.
Ma'am, in the inner circle, there are the natural numbers which contain numbers from 1 to positive infinite. Meanwhile, whole numbers are a bigger set of numbers which contain values from 0 to positive infinite. And the outer circle, the integers contain numbers from the value of negative infinite to positive infinite.
Okay. Agastya?
This picture shows that all numbers are integers, and integers you have whole numbers, and whole numbers you have natural numbers.
Okay. Yes, Parinita?
I was trying to tell the same thing as.
Okay. Okay, never mind. Yes, Sudhir. Last, we won't be taking any more opinions. Okay?
Ma'am, like these whole natural numbers, whole numbers, and integers are like sets, which in this natural numbers are the smallest set, and the whole number is bigger than the natural set because it adds 0 to the natural numbers, and integers are bigger than whole numbers and natural numbers. So the whole numbers and natural numbers are inside integers. And integers is the we call it universal set because integers is bigger than the whole numbers. So integers is the universal set of whole numbers, and whole numbers is the universal set of natural numbers.
Okay. Okay. Glad to see everyone putting so much of effort and everyone staying connected to the class. I can see nobody has lost the interest meanwhile in the midway of the class. But somewhere I did not get the answer that I was expecting. Yeah, none of you were wrong though. I wanted, do you think that this picture shows that all natural numbers are whole numbers and all whole numbers are integers? Hence, can we conclude
No,
it
ma'am.
that way?
No, ma'am.
No? Why? All natural numbers aren't whole numbers?
Part of.
Yes, ma'am, but not all whole numbers are natural numbers.
Ma'am,
I
they
did
are.
not say it that way. I did not say it that way. You might have learned all perpendiculars are all intersecting lines are perpendiculars, but all perpendiculars are not intersecting, right? So it's the same logic. It's like all squares, all rectangles are squares, but all squares are not rectangles. It's something like that. I did not say whole numbers are natural numbers. I said all natural numbers are whole numbers. Whole number has one
Yes,
extra.
ma'am.
All
Yes,
natural
ma'am.
numbers are whole numbers, and all whole numbers are further integers, right? Can I describe it like this? Everyone
Yes, ma'am.
agrees? Yes. So I
Yes,
was
ma'am.
actually expecting this, but never mind. I hope next time when someone asks you, you'd be able to conclude it this way. Okay? So over here in the coming up slides, we have quite a few quick examples of our day-to-day life, how integers are related to us everyday life. Firstly, we have temperature. Temperature is a very common thing. You people are grown up enough. You might have checked temperatures in your parents' phone or something when it's too hot or too cold, right? You start checking the temperature. So what happens when it's summer, when it's very hot, the temperatures rise. And when it's winters, the temperatures fall. Even there are places where it goes to negative, right? So positive rising. So we can say summers are positive temperature, winters are negative temperature, right? Similarly goes with height. The sea level is the zero. The sea level is the origin. The more you go upwards towards the sky, it's positive integer because you're approaching upwards. The more you go underwater, you're going downwards. So that's a negative integer. Okay. Similarly, directions. Also, again, this might be a part of your social studies or geography, whatever you have. The earth is divided into two hemispheres using by the equator, isn't it? Yes, no. So the more you go upwards towards the northern pole in the northern hemisphere, it's a positive thing. Again, further, when you're coming downwards towards the southern pole, it's a negative integer. Profit is obviously you're gaining something, so that's positive. Loss is what you had is moving out. So that's again negative. Okay. Earning and spending, same way. Earning means you're getting something, you're earning something. So that's a positive thing. Spending means whatever you had, you're going and buying chips and chocolates for you. Money is going out and you're getting in junk food, which is no way healthy, right? So ultimately, you're gaining nothing. You're losing the money also, you're losing the health also. So that's a negative integer. Okay. And same as with deposit and withdrawal. How many of you have piggy banks? What do you do? What the money you get, do you put it into the piggy bank or it's
I store it.
We collect the
You collect the money? Okay, good. Good then. Then you are into a positive track then. If you're collecting the money, that means you're depositing the money. That's a positive thing. Positive approach for life. You know how to collect and accumulate money. And if the piggy bank is just for show, you're having nothing in it, just for show it is kept. So then that's a negative thing then. Okay. Okay, all of you. So these are
Yes,
our
ma'am.
day-to-day life examples, how integers are very common. No writing on the screen, please. No writing on the screen, please. This is not erasable from my end. Thank you. Okay. Few fun facts about zero or other side of zero, whatever you want to say. Positive integers are obviously always greater than the negative integers because they are on the right-hand side. And as I told you, the more you go rightward, they are increasing the value. Okay. Zero is less than obviously every positive integer because it's on the left. Greater than every negative integer, again the same logic because it's on the right. And zero does not come in any positive or negative integer, any of the positive or negative integers. When we define integers now, you know how it is defined. Integer is a set of negative numbers, positive numbers, and the number zero. So zero is always kept separate. Zero has got positive and negative. Got it, everyone? Got it?
Yes, ma'am.
Yeah? Okay.
Yes, ma'am.
So everyone, is it interesting so far? Any queries? Arav?
No, ma'am.
no,
No,
ma'am.
ma'am.
No?
No, ma'am.
What no? Not interesting or no queries? Which one no?
No
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 query.
query.
queries.
Okay, I guess then it's interesting. Okay, now we will move forward to addition of integers. How do you add integers? Let me tell you one thing. When you have same symbols now, you always add. Same you add. Okay? Or like symbols. For example, if you have two positive integers, under addition, you add. Two negative integers under addition, again negative and negative, again you add. For example, 6 plus 7, if you have, that's 13, positive 6 plus 7. Negative 6 plus negative 7. Same symbols, na, both negative. Then also you add. 6 plus 7 is 13, but a negative 13. Okay, all of you?
Yes, ma'am.
Repeat myself.
Yes,
When
ma'am.
you have two positives, you add. Please no writing on the screen. When you have two positive integers, you add and the result is positive. Carry it forward. Two negatives, Then also you add, the result is again carried forward. Negatives, negative, negative. Okay? The main thing lies over here when they are not like symbols. When you have one positive and one negative. When you have one positive and one negative under addition, you do not add. You actually subtract. 7 minus 6 is what? A 1, right? Right, all of you? Over here, the absolute value which I taught in the very beginning plays a major role. I repeat, when you have one negative and one positive, you'd never add, although it's under addition, you subtract. And now what you do, you take the absolute value of the numbers. Absolute value of minus 6 is what?
6.
6. Absolute value of positive 7 is what?
7.
7.
Which of the absolute values is bigger, 6 or 7?
7.
7.
7.
And 7 was originally positive or negative?
Positive.
Positive.
So my answer is positive. Okay. I suppose change the scenario. See, I reverse the role play. Minus 6 was there, I make it positive 6, plus minus positive 7 was there, I made it negative 7. In this case also my answer is 1, but this time it's a negative 1 because the higher absolute valued number 7 is originally negative this time. So it's a negative 1. Am I clear, all of you?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Any confusion?
Yes, ma'am.
No, ma'am.
Great. Okay. So I'll start off with the ones who are quite silent. Natasha? Natasha, can we have you? Are you here?
Hello. Hello.
Yeah. Oh, hello, ma'am. Looks like you're
Hi, ma'am.
silent.
Yeah, this is Harshit's mom here. He's not at home. That's why I just joined it just to
No,
check
no
how it
worries,
is.
no worries. Okay, fine. Thank you so much. Okay, Shabana, are you a student?
Ma'am, no, I'm not a student.
Okay, okay, no worries. Okay. Anybody from the ones who have the cameras off? Shashrik, Yugan, Tanep. Tanep is most probably a student, I believe, because he was writing on the screen. Tanep? Okay, never mind. Parinita, sorry. Can you just guide us with this one?
Ma'am, so if the absolute value of the missing number will be positive, no, I mean negative, so it will be, ma'am, 10.
10, a positive 10?
No, ma'am. Sorry, ma'am.
Negative 10?
Ma'am, I'll just think and answer, ma'am. May I?
Yeah, sure. Take your time. Okay, by the time. Anyone else? Any of the boys I would like. Ritesh.
Yes,
What's
ma'am.
this one?
Ma'am, 9.
Positive or negative? And they're doing integers.
Positive.
Okay, very good.
Positive 9.
Positive 9 minus 2 is positive 7. Very good. Nananjay, this one? What plus minus 9 is minus 14?
Minus 5.
Minus 5, very good. Minus 5 minus 9 is minus 14. Ishi, minus 4 plus what would give you minus 14?
Ma'am, wait, can I think for a
Yeah,
minute?
sure. Okay. Arif,
Yeah.
can
Yes,
you please
ma'am.
guide us with this one?
Yes. That is -1.
The last one, minus 10 added to what should give you minus 11?
Can I just have a minute?
Yeah, sure. Atharva,
Yes, ma'am.
answer to this one, please. What added to minus 4 can give you minus?
-12.
Negative 12 plus negative 4. Don't you think it's negative 16? Negative negatives you are adding and the answer is negative. So in that case, I think your answer is wrong.
-4, ma'am. -4 is the right answer.
Correct. Negative 4 plus negative 4 is negative 8. Anyone from the ones who took time, Parinita, Ishi, and Arav, are you done with your answers? Okay, meanwhile, Agastya, for this one, what should be my answer?
This one is negative 10.
Negative 10. Very good. Well done. Okay. Those who were thinking, anybody, can I have the answer? Ishi.
Ma'am, is it -1?
Huh?
Arav Joshi here. -1.
Negative 1 for this one.
Yeah.
Correct. Correct.
Ma'am, can it be positive 18 for the fourth one?
Yes, Ishi?
Ma'am, positive 18.
Positive. 1 second. Sorry. For which one are you answering?
Ma'am, fourth one.
Okay, positive 18.
Yes, ma'am.
But positive 18 and a negative 4, that's positive 14 as the answer. Negative 14, Ishi. Ritesh, what do you think? What's the answer to this one? Ritesh, what's the answer to this one, Ritesh?
Excuse me, ma'am.
Ma'am,
Ma'am,
-10.
Minus 10, very good. Minus 10 minus 4, that's minus 14 as the answer. Okay, Ishi?
Okay, ma'am.
Okay,
Ma'am, I got the answer.
Parinita's answer left, I believe, just.
Ma'am, it's -9.
Yeah, the first one, minus 9. Correct. Okay, all of you, well done. So I hope you understood. See, those who took time, especially for them, and obviously for everyone, I'd like to give you a tip. Whenever you're getting such question, you don't have to think much. What plus 3 is 5? What plus 3 is 5?
2.
What do you do? 5 minus 3, right? You bring this one, this other hand, and positive 3 changes, it becomes negative 3. Correct, all of you?
Yes,
Do
ma'am.
the same thing over here. Suppose this was the one you needed to solve. So you can have switched negative 5 this side and it would have become positive 5. So negative 14, positive 5 is negative 9. That's very easy. You don't have to think much if you're getting stuck. And obviously, if you can do rapidly, then it's very good. Okay, I think I forgot. I missed Sudhir with any of the questions. Sudhir did not get a chance in this slide, right, Sudhir?
Yes, ma'am.
This question was missing. So can you tell us the answer to this one? What plus 10 is 4? That's
Ma'am, -6.
very good, Sudhir. Minus 6. Okay, all of you. So I hope everyone knows now how it works. Fine. Now we have few properties when it comes to addition of integers. Mainly 3: closure, commutative, and associative. The meaning of the properties lies in the words itself. Closure. Putting an closure to something, putting an end to something means what? Two integers, no matter positive or negative, when you are adding, it's an integer only. What do I mean by that? 3 plus 4 is always a 7. It can never be 7 by 2 in fractions or 0.7 in decimals or in percentage. No. Integers lead to integer itself. No fractions, no decimals, nothing. Right, all of you? Next comes the commutative property. Commutative, derived from the word communication. When two people are in communication, like let's say right now, so many of us are in communication, right? Although not necessarily everyone is speaking at the same time. Sometimes I'm speaking, sometimes any of you is speaking, sometimes all of us are speaking together. When we are in communication right now, is our topic changing? For example, when I'm teaching, I'm telling you maths. When any of you are talking or any of you start talking, are you talking of something else? Maybe let's say some of your school gossip or any other subject. Are you doing that? No, no.
No, ma'am.
Our topic is same, no matter who is speaking, right? So that's the scenario here also. Two numbers when in addition, no matter what is written first, the result is same. 3 plus 4 and 4 plus 3 is always the same number. Because 3 and 4 are the same numbers. No matter you are writing 3 first or the 4 first. Okay? And associative property is again the extended version of commutative property. Commutative property is with two numbers. Associative property is with more than two numbers. Fine enough, all of you?
Yes, ma'am.
Yes, ma'am.
Great. The last thing that I would like to teach you today is additive identity and inverse. Can anyone tell me what's the meaning of the word identity? Any of you? Yeah, Agastya?
Means like, how do you recognize somebody? Or like, what?
Something.
Somebody basically.
Okay. So what's the identity of a number? Is it the number itself?
Yes, ma'am.
Yes. So what's the additive identity of any number? 0. Because when you add 0 to any number, the result does not change, right? It's the same number. Correct, all of you? So additive identity of any integer is 0. And what's additive inverse? The meaning of the word inverse is opposite or reciprocal, right? So hence additive inverse of any integer is the same number with a reverse symbol. Positive 3, inverse is negative 3. Negative 75, so the inverse is positive 75. Understood? The same numerical value, just the sign reversed. Am I clear?
Yes, ma'am.
Yes, ma'am.
Ritesh, can you please quickly tell us 4 more than minus 7 is what? 4 more than minus 7, what is it?
Ma'am, -3.
Correct. So it's basically minus 7 plus 4, that's a minus 3. Okay, one more. Everyone, I would like to solve you. I would like you to solve, I mean. Everyone can solve this one and raise that once done.
Okay, wow.
I can see Dhananjay and Agastya already raising the hand. Dhananjay, are you done already?
No, I just raised my
20 plus 45, 65, 15.
Ma'am, can I tell?
Ma'am, A.
Yeah, Sudhir, I already heard your answer. Though, but still you can go ahead. What's your answer, Sudhir? I heard. You can speak it loud for the class.
15 rupees, ma'am. A.
Ma'am,
Positive 15.
ma'am,
Okay.
rupees
Yeah.
minus 30.
Minus 30. Who said? Ritesh?
Ma'am, me. No, Dhananjay.
Dhananjay. Okay. We have minus 30. We have positive 15. Anybody else? Atharva?
Ma'am, it's positive 15.
Okay. Parinita?
It's positive 15.
Okay. Okay. So, see, all of you. Dhananjay, your answer is wrong, unfortunately. Positive 15 is the correct answer. 125 rupees he had in his savings. He withdraws negative 105. My balance is positive 25 now. Okay. Again, makes a deposit
20, ma'am.
from here.
Ma'am, it's positive 20.
Yeah, sorry.
Yes, ma'am.
Sorry, my bad. Positive 20. Makes a deposit of 45, so positive 45. That would result in how much? Positive 65.
15.
Correct?
65, yeah.
Adding, not subtracting, because deposit is a positive thing. Positive 65.
Then minus 15.
Drawing, so that's negative approach, so negative 50 it is. So positive 65 and negative 50, that's
Plus
a
50.
15 as my final answer. So the final amount left in the account is a positive 15. Clear, everyone?
Yes, ma'am.
Yes, ma'am.